I'm not sure if you see this thing on the side. I'm gonna hide it. Okay, so hi everybody. My name is Winston, and welcome to the Data Science Club's first workshop of the term. Um, yeah, so we'll be going over data pipelines today, and what else? I guess before we begin, let me just talk a little bit about myself. I am in 4A geomatics, and data science for me has been more of looking at things like image classification, regression for like, you know, I don't know, let me think, for crop yield forecasting. That's one of the things that I've done before. But yeah, um, I'm fairly, I guess, acquainted with TensorFlow. And today I'll just share with you guys how we can build um, data pipelines in TensorFlow and Keras. All right. So before we actually begin with the actual workshop, I just want to say that I've designed this workshop mostly for beginner to intermediate data scientists. So it would be helpful to know about like Python, and maybe if you've done like a machine learning model in TensorFlow or done anything with like multi-dimensional arrays, that would be really helpful for this workshop. But overall, our goal in this workshop is to learn how to create TensorFlow datasets from various files saved on the disk and create input pipelines using, sorry, let me just mute these people. Okay, so we'll learn how to make input pipelines using the TensorFlow's tf.data module for an image classification task. And you guys will also gain some exposure to loading datasets and models from the TensorFlow Hub. So in terms of the outline, our workshop's mostly going to first just go over some background information about data pipelines, like the definition of a data pipeline and why we need data pipelines. And then we'll move into the bulk of it, which is going to be a live coding session on Google Collaboratory. So let's begin. What is a data pipeline? In the context of machine learning, data pipelines, they transport input data from a source to a machine learning model while applying transformations to the data along the way. So some examples of this is maybe we have an image domain task, right? Where we want to load data from a number of image files and then transform them. So perform things like resizing the image, normalizing the pixel values, and performing augmentations such as rotate, scale, and etc. And in terms of the text domain task, we might load in data from a number of text files and transform them by splitting sentences into a list of words and just removing stop words and making the words lowercase. So you might ask, like, why can't I just load the entire data set into memory, right? Like sometimes when we're first starting out, we might have some projects where we are just loading like our data directly into a an array. But what this actually does is that if you're loading like a small data set into memory, that's okay, right? But if you have something large, like maybe a data set that's bigger than 5 gigs into your memory, you'll actually see that you'll run out of memory really fast, and even with a lot of RAM, because it's generally we're not like it's one thing to load the data set into your memory, but when we're actually training the model, like we actually create more permutations on this data set, right? So we actually need to stream the data from the disk instead. And though Hadoop is something that we could use, this workshop will specifically be looking at data sets within the TensorFlow library and the data module. All right, so that brings us to the motivation for data pipelines in machine learning and TensorFlow specifically, which is where we will be using the tf.data module to load our data sets into these, or sorry, we load our data into these tf data sets. So we ensure that they're not entirely loaded into the memory. And also there's some performance gains that we can get out of this because there's some function or there's some methods that we can perform just to make sure that our data isn't actually bottlenecking our training process. And as an additional, like, just a nice thing, we can actually simplify our like complex loading slash pre-processing code to something that's a bit more readable and extensible. So overall, efficient data pipelines, they're very vital in large-scale ML projects, and especially for things like company projects. If you guys are going into your co-ops, you'll definitely see data pipelines in some form of or another, because there's no way that they're able to load their terabytes of like data into their actual memory. Anyways, that's about it for the background information. I don't want to like spend too much time on the background. We're actually going to do some live coding, and hopefully you guys can learn something here. We're not actually using Spark for this tutorial. We're just looking at the TensorFlow data module, which I think is really helpful. Yeah, I think earlier I sent the link to this stuff, but let me just send it again. Oh yeah, so Spark is essentially it's a framework for distributed computing. So we just distribute all of our computing into, different clusters of computers, and that essentially makes like a supercomputer sort of. But yeah, for the first link that you guys see, the live coding follow along, that actually has the code in it already. But if you look into the live coding parentheses no code, that has doesn't have any code in it. Let me just quickly show you guys what it looks like. Yeah, so this is the follow along. We have some code already, but for the actual live coding, there's nothing in this cells, and I'll actually go over these parts with you guys together. Oh yeah, you don't need a GPU session for this. It's fine if you just run it on CPU. All right, so just wanted to make sure that everyone can access the links and get into the actual Collaboratory notebook. You might have to copy it to your drive. All right, so the first thing you want to do when you load into this is just to run the first couple of cells under import libraries and utility functions. Okay, so this part, it might take a really long time, make huge data, because we're actually, I wanted to show you guys something with like loading really big data sets. So we're just going to be making a data set that emulates like an image file that has 3,000 samples of an image that's 256 by 256 and has 3 color channels. So while you guys are waiting for that to load, yeah, that's my Gmail name. All right. So while you guys are waiting for this to load, I'll just go over like the overall outline of what we're going to be doing in the live coding session today. So first, we're going to look at the basics of the tf.data dataset module, or it's an object actually. And this is the basis of building our pipelines. So essentially, we're going to be loading our data into the datasets and then performing like some methods on it and chaining them together to create the pipeline. And then after that, we'll look at how we can load in data from, sorry, I think somebody is trying to join. Oh shoot, I should. Okay, there's a lot of people waiting in the waiting room. Yeah, sorry about that. I didn't notice that there were so many attendees. Okay. Hopefully people can see the link to the Collaboratory notebook. I'm not sure about the new people if they can see the chat history, but definitely let me know if you can't see the notebooks because I'll send you the link. All right, so back to where we were, the outline. So after we look at how we can create data sets from data in memory and disk, we're going to look at creating an image classification model using our data pipelines that we just made. Okay, let me send this here. All right, so I just sent you guys the link again. The first link is going to be a notebook with all of the cells completed. The second link doesn't have any of the cells completed. So it's up to you guys, whichever one you want to follow along with. Right now, I'm working on the one with no cell because I actually want to code it out for you guys to show you. All right, I think that's about it for the outline. Let's actually get into working with TF datasets. All right, so the first thing I'm going to do here is just going to create a list of 10 numbers. So take a look at that. And indeed, we do have a list of 10 numbers. So I'm going to make the TF dataset. And I'm going to do the from tensor slices. It's okay. Oh, yeah. I'm not sure. I'm sorry if it bothers you guys that my keyboard's like loud. But anyways, yeah, so I'm going to be creating this data set from the actual Python list that we created. I don't want you guys to worry too much about what from tensor slices mean yet, because we haven't gotten to that part. But all right, so we've created our data set, right? And now let's take a look at it. We see here it's an object called a tensor slice dataset, and it says shapes is empty and the type is int. All right, so I'll explain later why this shape is empty, but for now, let's try something pretty intuitive. We'll try to index it. Oh no, so what happened here, right? We see that it's saying that this object is not subscriptable. Well, actually, these data sets, they aren't actual like arrays or anything like that. They're actually iterable objects, right? So we can't actually access a specific element like an array. If we want to view the contents of this data set, we can iterate over it using a for loop or turn it into a Python iterable object and use like the iter next method to look at stuff in it. So let's take a look at what this means. I'm just going to iterate over it using for loop, right? And now you guys see, we actually see everything inside of this data set. And we can see that we have tensors, which are essentially just, sorry, let me just omit someone. Okay, so we just have tensors, which are essentially, you can think of them as NumPy arrays or multi-dimensional arrays. And it says it has a shape of nothing because this is actually a scalar value. It's not an array, it's a number. So that's why up here we see that the shapes is nothing. All right, so back to my previous point. Let's try to view the thing by making it an iterable, a Python iterable object, and then calling the next on it. All right, cool. So we see here that we just got the first, element from this data set. So that's pretty cool. What else can we do? Maybe we can iterate over it, or sorry, get the list of the iterable object. And it returns something similar to what we had above. But actually, guys, don't do this. Like, never ever do this. I'm just showing it to you guys right now because like I just wanted to show you guys what's in it. But when we do this, we're essentially loading everything inside of the data set into our memory. And then I got a message from a question saying, can we put the next iter in the for loop? I don't think we can actually, because we're not, yeah, it's weird. I don't think the for in loop is essentially doing the iter for us already. So to answer your question, we can't do that. Okay, so now you guys kind of have like a general gist of what's happening here. do you guys have any questions about like what I just showed you guys so far? A data set is a generator. Yeah, it's a generator. It's like an iterable. And I guess we can think of it also as a generator. Yes, you're correct, Fahim. You don't do list iter dataset because it loads everything from the RAM into the RAM. Sorry. All right, so I think I'm going to move on to the next part now. In this section, we're actually going to look at things that we can manipulate the data set with. Starting off, we have the dataset shuffle. So I just gave you guys like quick TensorFlow documentation here, but essentially what this does is it just shuffles everything in the array. So I'm going to go against my own word and do the list iter thing, which is very bad, by the way. Okay, question from Justin. Actually, later on, we're going to be loading in a data set from pandas. So I'll show you guys how to do that as well. But generally, yeah, we use TF. Or you want to use TensorFlow because of the capabilities for this iterable object, which does not store everything in memory, as well as some performance functions that TensorFlow gives us. What would be proper practice? It would be proper practice to, first of all, not do this list thing, but we're not, I just wanted to show you guys what's in it. And if we wanted to see what's in it, we can do a for loop like this or do the next iter. Good question, Dominic. All right, so we're gonna take a look at what shuffle does. Remember, we had this data set, it's just listed numbers from 0 to 9, and we'll do a shuffle. So we have to give it a buffer size here, and this just tells us like how many of the elements that we're going to be storing temporarily in our RAM when we're doing shuffling. Okay, so you guys can see here that we just made a shuffled data set, and yeah, it's it's shuffled, right? But let's see what happens, because we can actually give it a buffer size that's like less than the number of, or the length of the data set. What happens now? We can see that only a couple of things were shuffled. It seems like it didn't do really well. Like the rest of the data set seemed rather intact, right? So that's why you want to make sure that you try to set a buffer size that's as close to the length of your data set, but you don't want to go too low. On that same note, you can actually go a lot higher. So if I wanted to do, I don't know. Okay, no, this is bad. But generally, if you go over the number, oh yeah, this just crashed my thing. All right, never mind, don't do that. Let me just do everything back again. Sorry, it's gonna take some time. Okay, so what does the number in the argument mean again? It just means that it's how many like samples that we're putting aside into the RAM to allow our shuffling. So if I put in 10, it means that all of these elements in here are loaded into the RAM and then they're shuffled. When I put in 2, only the first 2 elements are drawn from this data set and shuffled, and then the rest are just kind of left as is. Okay, I think I just finished loading up again. All right, so that's the end of shuffle. Let's look at filter. Sorry, just give me a second. So filter, it's similar to Python's filter method, where we can filter a data set according to a function returning a Boolean. I realize that we're actually running a bit behind right now, so I'm just going to copy and paste from like the notebook that I have, sorry, from the completed notebook, and then we'll take a look at what that happens there. So as you can see here, we're still doing the list iter thing. On the data set, we apply the filter function with a lambda function that essentially says just pick out all of the even numbers here. So yeah, that's filter. We're gonna move on to map. If anybody has any questions about filter, feel free to put it in the chat. But for map, this is actually a really big function because it's something that we will be using a lot in like our data sets, and you'll see it a lot too in like data sets that other people make. So this essentially, it just maps the function to each of the elements. Gonna make sure everyone gets admitted. There's still people joining. Yeah, so as you can see, we applied the function of x times 2, or element times 2, and we multiplied everything by 2. And then we'll take a look at the take method now. So essentially, the take method allows us to create a new data set using a specified number of elements from our original data set. So what do I mean by that? Dataset.take3 means that we take the top 3 elements from our original data set, and then we create a new data set with it. And I'm just list iterating it again, just to show you guys what happens. All right, so you guys can see that indeed we did take the top 3 elements from our original data set. Next thing, we're gonna talk about batch. So the batch function, what this does is that it combines consecutive elements of like the array into batches. And in the context of machine learning, batches are essentially just like a number of samples that we show to the model every time we try to update the model during the training phase. Yeah, and I'll show you guys what happens here. So as you saw earlier, our tensors didn't have any shape, but now we have a shape of 3 because what happened is that everything got grouped into like a 1D array, right? So we have, 0, 1, 2, 3, 4, 5, and it's all grouped. And then you'll also notice here that we have the remainder 9 on the bottom. And if we didn't want to, oh, actually, let me first show you guys. Okay, so if I removed all of like the iter stuff, we're just going to look at the definition, right? We see that we have a none type here. So what does this none type mean? It just means that it's a placeholder number. As we saw earlier, we had tensors that were ranging from 3 to 1. And none essentially means that there's a non-determinate size on this tensor. Okay, so let me show you guys. If we use the drop remainder equals true, which means that we drop the 9 from our data set or from our batching, we can see that our shape has turned into 3 rather than none, because now the shapes of every batch we create are determinate. And just to quickly show you guys unbatch, what it does. So unbatch, it essentially just undoes the batch operation from like if we did it, and it also removes like a dimension. So let me first do the list iter thing. Yeah. Right? So we see that we have batches of 3, but then if I add the unbatch into it, we get back our original array, or original data set before we did the batching. So yeah, this is essentially just what it does. And that's about it for all of the manipulation that we can do on the data sets. Does anyone have any questions about any of the functions that, or methods I introduced? All All right, so let's move on now. We're going to talk about is unbatch any different from NumPy? Um, I'm not too sure about that because I've never used NumPy's unbatch method, so I can't answer that. NumPy flat. I don't think so. And I assume that what NumPy flat does, oh, actually it is different because unbatch just removes one dimension from the data set, while flat it flattens everything and makes it into a one-dimensional array. Feel free to let me know if I'm wrong though. Unbatch uses iterators though, right? Yes, yes. So everything that we've done here so far, they still return the data set. They didn't modify the original data set. They just returned a new instance of the data set that's modified. So they are functional methods, if you guys know what that means. Actually, I'll explain that a little bit. It just means that like what these functions that we apply on the data set, they don't actually modify the original thing. They just make a new one for us. Yeah, and another thing is NumPy flat is with the NumPy arrays and not iterators. You're correct. Okay, so let's move on to the next section now. We'll talk about pipeline efficiency and how we can actually optimize the pipeline, right? So our first function that we have is called Dataset Cache. At the moment, I, I'm just going to talk about like what it does, maybe not give any examples yet because we'll look at that later. So caching, we can add it to like our any functions that we do, right? So if I do cache here, it still returns like the same batch data set, but I mean it's called a cache data set now, but the shape still remains the same. So nothing really happened, right? But what this meant was that we cached what happened here. So that allows us to create optimizations in our pipeline later on when we start to, put more methods together. And then prefetching. Prefetching, essentially, it allows us to specify a number of samples to prepare in the background while the current sample is being used to train a model. So this is actually a really vital component of data pipelines in TensorFlow because it allows us to basically concurrently prepare the data before the model is ready to take in any more. And it just ensures that we don't have any bottlenecks that's caused by like the GPU waiting for the CPU, or sorry, the model waiting for us to process the data set. In general, it just makes things a lot faster when we put them into our pipeline. So, okay, now let's actually talk about what's a use case to concurrently prepare the data. Right, so essentially that's the basis of how we're going to optimize our pipelines, because without a pipeline, you can still do all the same things that I just showed you guys here, but what happens is that while after training one set of samples, we're going to be waiting for the processing to happen again and then training on that sample. But with current preparation, we're actually preparing before we're training the samples. I don't think I really know how to show you guys like visually, but let me know if that makes sense for you, Dominic. Yeah. Okay, so we'll take a look at chaining together methods now. Again, just in the interest of time, I'll write this out for you guys. So what I'm doing here is taking the original data set, and then I'm gonna apply this function lambda x plus 1. So adding 1 to everything in the data sets. And then notice here, there's one thing that we have, num parallel calls. This just allows us to parallelize our like our mapping function. And I'm not going to put in any numbers. Instead, what I highly recommend you guys to do, if you guys ever run into this, is that you use the tf.data auto-tune. And this is just a constant number that tells TensorFlow to take control of like optimizing the number of parallel calls to use. Can you do async request with prefetch as well? I'm not too sure about that because I've never used it before with async request. So I'm sorry, I'm not sure how to answer your question, Kevin. And right now in this, also one thing is that we're working with a offline data set right now. We're not really looking at like online data sets that we're fetching from the web or some API. Okay. So after our map, we're actually going to chain it with the filter function. So let's just say lambda x larger than 3. And we're going to filter everything out that's less than 3, essentially. And the next function I'm going to show you guys is cache. So as I mentioned earlier, caching, what it does is basically caches the operations above it. So we're going to be caching map and filter. And then every time we actually like run this data set or something iterates over the data set, we don't have to run these functions again. So that's why it's like caching is one way that we can optimize our data sets. And then the next thing we want to do is shuffle the data set. Finally, batch it. I'm just going to say 2 and also use num_parallel calls equals tf.data.auto-tune just to tell TensorFlow to take control of the optimizations. And finally, we always want to end off our dataset pipelines with prefetch. Right, so prefetch again, it requires one argument, the number of samples to prefetch, but I'm just going to pass it off to TensorFlow auto-tune to take care of that. Okay, so now we've created our pipeline. Let's actually show what happened in it. Oh, sorry, I wrote df. Okay, so as you can see, we've applied all of these functions in like a chain, and we got this data set out of it. And in it, we see that we have tensors that are of shape 2 and 1 due to the batch. And we've also shuffled and added 1 to every element in this data set. Oops, I think I just realized that this cell should be down here. Okay, so far we've only looked at data sets containing one array, but in actual machine learning, right, we usually have more than one array, which is where we have our labels and our features. So let's take a look at how we can actually input something that's more, I guess, practical into our data sets. So again, I'm just going to copy and paste here in the interest of time. As you guys can see here, the first thing we did was that we created a feature, like a feature that's a 3x3 array, and there's 4 samples of it. And then the label, there's also 4 samples for that as well. And we put it into the from TensorFlow slices method in a tuple. So let's take a look at what happened and what we created. Does shuffling the dataset make a difference if we use a random sampler in our data loader for our model? I think if what you mean by that is that you already like shuffled while loading in the data, then shuffling, you don't need to do shuffling again. But the thing is, with data pipelines, you kind of have more of a fine-tuned control over how much RAM you want to use when you're shuffling. So that's the main thing with data sets, is more about efficiently like managing your memory. All right, so back to here, we see that our structured data set actually contains two shapes now. The first one is a scalar, and the second is our 3x3 array. Let's just iterate over this. All right, so what do we see here? We see that indeed we have our scalar value up here, and then our 3x3 array down here. And there's 4 of them because I created 4 samples, right? So what's the actual type of this though? The type of one of these samples that is a tuple, right? So what does that mean? It means that when we actually want to iterate over it, rather than doing like the 4x that we usually did before, we actually have to unpack these tuples, because every time we iterate over it, we're getting returned a tuple that's like has 2 things in it. So here you see that I did a for label and feature in the datasets just to unpack that tuple. And then we're going to be printing out what's in there in each of the label and feature. And just by the way, guys, label is a tensor, is a tensor. And tensor has this method called numpy, which converts it into a numpy array, or in this case, it's a float. So do you guys have any questions about this part so far? If not, we'll take a look at how we can actually do mapping on this conjoined data set. So as I mentioned earlier, we have a tuple, right? We get returned a tuple. That means that if we're actually doing our map function, we can't just do lambda x because x is a tuple. So we want to unpack it. And we can also do like, lambda x, y. But then I don't think there's you can actually do like x plus 1, y plus 1, like this in the lambda. Like it probably gives an error. Let's try it out. Okay, I misspelled it. Yeah, so you can't do that. So what I done here instead is just passed in an actual function that I declared that takes in the label and a feature and adds 1 to it. When we run it, you can see that indeed we did add 1 to each of our like the tensors inside the data set. All right, so that concludes the part of the basic mechanics of the TF dataset. Now let's look at creating data sets from data that we have in our memory/disk. I think earlier we already kind of looked at from TensorFlow slices, but this time I'm going to use my very large data set file that I have. Just to show you guys how big of a file this is. It's 4.72 gigabytes. So it would obviously take a really long time if we just try to load in this data set normally. Quick tip for you guys who use NumPy. If you want to load in a really large data set like this, you can pass something, argument called mmap mode. And this just tells, it tells NumPy to use a memory mapping, which essentially means that we won't be loading everything into the RAM at once. So let's run that. It's really quick to load in the huge data set. And as we can see, we essentially get back our array. And you can just treat this array as a normal, like any normal array or any normal NumPy array. All right, so the next thing we're gonna do is we're just gonna create labels for this. The file format for the dataset file is a .npy, so NumPy file. All right, so we've created the labels for the dataset. Now let's do the same thing as we just learned above and pack the label and the data together. So again, using from tensor slices, and we've created our dataset. Let's take a look at that. As you can see, we have our scalar value for our labels, and then our image, which is a 256 by 256 3-channel image. And when I say 3-channel, I just mean like red, blue, and green channels. Take a look at the first thing from the data set. Okay, this is taking a while actually. Okay. So we see that we have integers for the labels and our image, and that's kind of what we were expecting to see. Oops. Oh, okay. Sorry, guys. All right, and then again, if we want to look at what's inside of the data set, we can just unpack it using the for loop with our unpacking. So yeah, you guys can see here that we just created, we see our label of 1 and our image. All right, so now let's actually look at something a bit more interesting. We're going to be creating a data set from a structured image directory. First thing I'm going to do is just load in a data set from the TensorFlow datasets catalog, right? And my problem is the image classification. And also, I'm going to be looking specifically at the TF flowers dataset. So in this TF flowers dataset, we just have a bunch of images of flowers with their labels of what kind of flowers they are. How large is the file? Well, the original NumPy file that we loaded in was 4-point-something gigabytes, 4.72 gigabytes. So it's decently large, but it definitely will bring us near crashing the Collaboratory notebook if we try to load in the whole thing. All right, so you guys have seen what's inside the TF flowers dataset. Let's actually download this. We're going to be using the Keras utility to download the file. Okay, now it's downloaded. Let's take a look at what it returned. As you can see here, it just returns where we downloaded the directory and saved it in which folder it was saved in. Because I can't really see what's inside there, I'm actually going to move it into our local workspace. So let's move that and update the flowers directory, the files directory to where we just moved it to. So let's take a look at what's inside. So as you can see here, this is our directory we just downloaded, flower photos, and we have the labels for each of the different categories that we're trying to categorize. And inside each folder, there's a lot of photos for each of the categories. So this is a structured folder, right? As I don't think I showed it above, but oh yeah. So down here, you can see that there's some documentation for this, for like the next function that we're going to be using. I'm not going to go into too much detail with it, but essentially, if we call this function, it's going to load in our images from this directory and put it into a data set. So if we just take a look at this flowers data set, we can see here that we have our images And because there's batching, you see that there's none here. So what if I unbatch it? You can see that indeed we just get our images and our labels, which is a scalar value. All right. So next thing we're going to look at is creating data sets from a CSV file. So the first thing, I'm just going to be loading it from the sample data that's already inside the Collaboratory notebook. And we're going to be looking at the California housing data set. So let's load this in using pandas. And let's see what's inside here. So as you guys can see, we have all of these different features. And for this problem especially, I want to, let's say, predict the median house value with these features. So the first thing I'm going to do is just going to separate them out using locate. Yeah, so earlier we were able to load in all of our images because of dataset, or because of the data set, right? We don't look at our RAM right now. We haven't actually like went up at all when we loaded in those data sets or that flower photos because we're using data sets. And that's like the power of TensorFlow data sets. All right, so I've split everything into the labels and features. Let's have a look at that. So housing features, housing, or sorry, the labels and the features, and yep, looks like it's been split. So now what we can do is use the function that we've always been using, which is the from tensor slices, and putting our housing labels as a NumPy array and the features as a NumPy array into the tuple. And then if we take a look at the housing data set now, yeah, we can see that we have our labels, scalar value, and 8 features. Okay, so now let's actually look at an experimental method from the tf.data module, which allows us to make a CSV dataset directly from the file. In the interest of time, because I know that we're almost, getting to the end of it, I'm just going to copy and paste some code from the follow along. All right, so we see here that we made our housing data set, and let's take a look at that. We get an ordered dictionary back this time, but this has all of the labels for the different features that we have. So that's pretty neat. Anyways, does anyone have any questions at this time? Because now we're going to actually go into a full workflow and create a actual like data set or create a model. All right. Yes, Dominic, it is neat. All right, so we're going to be loading the TF flowers dataset from the TensorFlow dataset. Oh, sorry. We're going to be loading it from here this time. But instead of doing what we did earlier where we downloaded the file, we're going to be using the tf.ds.load function. And we just have to give it the label of the data set that we want and how we want to split the data. As you guys can see here, we have train 80 and train 80. What does that mean? If we take a look at split here, this tells us in this data set, they had like train and 3,670 examples, right? If I go back to something else, maybe beans, right? We can see that the split is into test, train, and validation. So if I'm exporting the beans data set, I can actually say I want it to split with the train and the test. And then it's going to download this data set. But again, we're going to go back to our tf.flowers data set because that's what we wanted to work with. Okay, this is actually taking quite a while. I don't know why it's doing all of this. Okay, actually it's done. But yeah, let's use our tf.flowers again. We're just saying that because we only know that they have one train split, we're going to split that training into 80% goes into our actual training data set, and the rest of the 20% goes into the validation data set. All right, so it's downloaded. Let's take a look at what's inside them. If you guys notice here, I gave it a with info argument equals true and as supervised equals true. And that just tells this one, it tells tf.load that we want to get the labels, and with info just tells us that we want the info class. So the info class is pretty useful. I'm not going to go into too much detail about what the tf.ds module contains, but with this class, we can actually just display like our samples. As you can see here, we have tulips, and that has a index array of 2, and sunflowers is 3. And if we actually look at this, indeed, we can see that, okay, no, never mind, tuples isn't at 2. Anyways, ignore what I just said. Yeah, so show examples, we just take a look at the top 3 images. For some reason, it's duplicating them. Not sure why. But one thing that I do want to draw your attention to is how we can use the info data set to actually convert our numerical prediction labels into the actual string labels. So info is a data set, or is an object, right? We can call features, and then features just returns a dictionary, and then we'll do labels, label. And within it, you can't see it here, but there's that function, int to string, and it just tells us like if we want to see what 1 corresponds to, what 0 corresponds to, etc. Oops. Yeah, so that's it for in terms of loading the data set from the TensorFlow Hub. Let's actually build our pipeline now. Okay, so first thing we notice with our sample is that some of these images, they aren't the same size. With the model we're working with today, we want to make sure everything is, all of these images are in the same size, right? So we're going to declare a function that does the resizing and rescaling. So it takes in an image, label, and size. So the first thing we want to do is just convert this image into a float. 32. And why is that? Let's actually take a look at train data set. I'm gonna look at the first example. And if I just show the image, you can see that in these, it's an int number inside of each of these pixels, and they're from 0 to 255. We actually want it to be somewhere in the range of 0 and 1 instead. So the first thing we do is cast it to the float. And then the next thing we want to do is we want to resize the image. And we're just going to give it the size as up here. And we will finally change it from a range of 0 to 255 to 0 to 1. So let's do that. That's our function right here. Let's actually take a look at what happens when we run the function. So again, just copy and pasting code here. We're running out of time a little bit, but that's okay. I'll keep going if you guys want to stay. Oops, I forgot to do my utility function. Right, so I just wrote some utility functions to visualize the augmentation, compare it to images, basically. Yeah, so we just pulled in the first sample, did the resizing, and then pulled it out of the tube, unpacked it into their relative variables again, and then shown the visualization. So as you can see here, we did do the resizing. Okay, so we also need to make another function for augmenting the image. I think there's a bit of a mistake here. I should actually put this up here. So what we're gonna do with the augmentations is just run a bunch of like flips, change the saturation of the image and change brightness, hue, that sort of thing. So I've just copy and pasted the code. We're going to do a random flip left, right, flip up, down, saturation, brightness, and hue. And again, we can maybe look at what happens with the results. I'm just gonna quickly reconstitute this part. Yeah, as you can see, it does do the augmentations. And notice that every time I'm running it again, it creates a new thing because the randomness is just, it's not deterministic, right? So every time I run this, something random happens again. All right. So at this point, let's try pipelining everything together. So the first thing we want to do is we want to resize the image. And the next thing is perform the image augmentations. So I put the code down here. As you can see, the first part, we actually use a lambda function because we have an extra argument here for size, right? And we want to be able to pass in this size in here. So that's why we use the lambda. Let me know if I should explain that a bit more. But the next thing we're going to do is just use the image augmentations function. Oh, something happened. Image size is not. All right, so the pipeline has been created. And let's just show what happens with what we get with the pipeline. Yeah, so as you can see here, we resized the image to 256 by 256 and applied our augmentations. All right, at this point, let's define the model. We're close to being done, guys. Okay, so I'll be using the MobileNet v3 small. It's just an ImageNet classification model that's really small and it's quick to load. So that's why I'm using it primarily. But let me just show you guys this TensorFlow Hub where you can find a bunch of different models, right? So how I found this model was that, okay, I see that my problem is the image domain problem and its classification. So I go into here. We see that we have a bunch of stuff here, but generally I'm gonna look at image classification collection. Okay, actually this is not what I looked at. I looked at the image collection. And in here we see like all of the different models that we have. But what I was interested in was the MobileNet v3 and the small version. Notice here that it says that images must be in this size. So that gives us a hint to like how big we need to resize for our actual model. Click into classification. And now we can copy the URL. So we'll place the URL here. Run that. And then as we saw earlier, we need a image size of 224 by 224. So that's what I just defined it up here. And another thing is that I made sure to do the input shape is 224, 224, and 3. Right. Why is the image different on each next iter? This part? Because we're applying the random augmentation to it. So every time it runs, it's random, right? It's not determined. That's a good question. So every time I run this, a new random thing happens. And it's not the same thing that happens every time. All right. So going back now, we're going to just get the number of classes and put it into this variable num classes with the info class object, sorry. And then we're gonna define the model structure. So we're using a sequential model. I'm not going to go too much into detail about like how these models work or anything like that because we're focusing on data pipelines. But essentially, I have an input layer that uses this input shape. And that just tells us each image has to be in this shape. And then the next thing we're going to do is the hub.keras layer. And this just tells us to download this model from the link that we just visited and place it in the middle of our model. And the last thing we're going to do is just because this model, it produces like classifications on like 1,000 something different classes. We just want to look at 5, right? Our flowers or tulips or whatever like that. And then we're gonna condense all of that into 5 and do a softmax activation. So let's run that. It's downloading the model now, and it's finished downloading, and we'll build the model. So as you can see here, we just reconstituted the 1,000 classifications to 5. And now we'll compile the model using a Atom optimizer with a sparse categorical cross-entropy loss. And, oh, okay, so this is the part where we're going to actually make the pipeline. So first thing first, we want to make a pipeline on our train DS dataset, right? We're going to map our resize and rescale function. I'm just going to copy and paste here. And the next thing we want to do, because that we know that this resize and rescale, it doesn't do anything random. It's always deterministic, meaning that we get the same results back every time. I'm just going to cache this to make it faster. And then I'm going to do the actual image augmentations. This produces random results every time we run the pipeline. So that's the reason why I put the cache above and not below this augmentations. And then we're just going to shuffle it on the size of, on the entire training data set, and then do batching and prefetch. So that's our training data set pipeline done. Next, we're going to look at how we can pipeline our validation data. So with validation data, we're not actually going to do any augmentation to it other than resizing and rescaling, because we want to check to make sure, essentially with our augmentation, we're just doing it on the train data set because we want to make sure that the model can, handle some extra noise. But when it comes to actually validating the data set, we're just going to give it what we would normally give it in an operational setting. So the first thing we want to make sure is that we resize this these images and then do a cache to it. So we want to make sure that the image size of the validation images are the same thing as what goes into the training. Next thing, we just do the standard sort of thing where we shuffle the data set apply a batch size to it and then prefetch. So we always end off with prefetch. This just ensures that we have a really optimal like pipeline. All right, so the pipelines are created. Let's actually fit the model now. As you guys can notice that I'm not actually doing anything to the data sets. I'm passing them as is for the X, or yeah, for the features and for the validation. Sorry, not features, for that. We're just passing in the data sets is what I meant to say. And I'm running it for 5 epochs and doing 10 steps per epoch and 10 validation steps just to keep it quick. But of course, it's still going to take a while. So with the time that it's taking to load now, do you guys have any questions about anything? Anything at all? You can ask me. Okay, why did we convert the pixel values from integers to float? So the reason why we converted the pixel values from an integer to a float is that we wanted um, all of the numbers, all of the pixel values to be within the range of 0 to 1, right? We didn't want them to be in, I believe it was 0 to 255, because usually models tend to prefer having a normalized number. Also, are you able to specify single precision floats? I'm not too sure what single precision floats are, so I can't really answer your second question. I'm sorry, Andre. All right, so we're still training. But as you can see, we're getting pretty good validation accuracy. All right, so we just finished training. Let's actually create predictions now. We'll grab one sample from the validation data set and then create the predictions by using model.predict. And here's the interesting thing. We do numpy expand dimensions. Let me show you guys what happens when we don't expand the dimensions. Something really weird happens. You know, we get a huge ass like error code. But essentially, what this error code is caused by is that with our test image, it's a just one image tensor, right? But because in our training and validation process like pipeline, we specified that we used a batch. So what that did was that it added an extra dimension to the tensors. So if we actually want to be able to pass in something like, oh, I forgot that that was a tensor. But anyways, yeah, so we need to make sure that for our one test image that we're putting in, we extend that dimensions to like sort of emulate having a batch. Let me put that back. You can see here that we produced our predictions. And essentially the highest number is the number that we're going to say that the model is most likely, or think what the model thinks that the label was that was most likely. So let's actually show the image and its predicted numerical label. It's not a numerical label because I used the get class name utility function from above to convert this numerical label into a string label. So as you can see, we predicted that this image contains a line, and I think that's correct. Let's now look at, let's manually validate a whole batch of validation images. All right. Oops. So we can see here we have our predicted and actual labels. Seems like this one was correct. This one was 2, roses and roses, tulips, tulips, sunflowers, sunflowers. So it seems like our model is actually pretty accurate. Let me see if I can find the wrong example. Okay, so this is one. Predicted is sunflowers, but actually it's a rose. So that's one example of where our model went wrong. But yeah, that brings us to the end of the workshop. I hope you guys enjoyed it. And in this workshop, you learned how to create a TensorFlow dataset from arrays, CSVs, and a structured image directory. We also looked at manipulating the datasets and forming data pipelines. And we finally used the data pipeline in a full um, image classification task and model creation sort of task. Yeah, I think that's the end of it. And one more thing, I just want to plug our social media. So, like the Data Science Club Discord and YouTube, where you can find our previous recordings of other workshops we did. Okay, I'm just going to click into it. So, as you can see here, we record all of our workshops and you can go back and view it at any time. So, if let's say you wanted to look at GANs or whatever. Anyways, that's it, everyone. Um, oh yeah, and one more thing, we also have a podcast in our for our club. So I believe that yeah, it's called the Unlabeled Unstructured podcast, and it's run by uh, sorry, I can't pronounce your name, but it's in the chat right here. It's really cool because the host of these shows they talk to different people in the data science industry. They look at things like working in the industry, what it's like to get co-ops, and yeah, there's a lot of information in that. And Jai is the name of the podcast VP. Anyways, guys, definitely check out our Discord. You can find me on there under the execs, and I'll be sure to answer any questions that you guys have. You can DM me and ask me questions. Anyways, that concludes it. Everyone, thank you so much for coming. I'll make sure to, in the YouTube video that we upload, to have like the full completed notebook with all of the notes. All right. Thank you guys so much. Have a good day. Bye, guys.